If a trinomial has a quadratic term with a coefficient that is not equal to 1, then it can be factored by grouping. So we have no common factor to remove. If we look at our numbers, for example, we have 2, -5, and -12. No common factor to remove. And we do not have x in each term, so we cannot remove x from each. So there's no common factor to remove. And as we mentioned, the leading coefficient is not equal to 1. So what we do is we focus on the middle term, -5x. The variable with a power of 1 must be split into two terms, so two groups of terms with common factors can be created. So this x has a power of 1, so this is the term we're focused on. And we're going to split -5x into two terms so that we can create two sets of terms. The two terms that we switch -5x to have a sum of -5x. So -8x plus 3x have a sum of -5x, the original term that was here. But by doing so, we now have one set of terms that can be grouped together and another set of terms that can be grouped together. And when we follow the grouping method, as we saw earlier in the chapter, we will wind up with the factors x minus 4 times 2x plus 3. But let's take a look at this process from start to finish to see how we land here. So you'll be asked to factor by grouping and check the answer for the polynomial 2x squared minus 5x minus 12, the expression we were just working with. So what do you do in these cases? Step 1, multiply a, the coefficient of your quadratic term, and c, your constant. So in this case, you'll be multiplying 2 times -12, which will give you -24. And now you want to find two factors of AC, which in this case is -24. You want to find the two factors of -24 that have a sum equal to b, which in this case is -5. So we'll start by looking at 1 times -24, since that has a product of -24. But the sum of these factors is 1 minus 24, which is equal to -23, and that does not match the coefficient of our x term, -5. So 1 and -24 are not the factors of -24 that we are looking for. So let's take a look at two other factors. 2 times -12 will give us -24, as we know. But when we find the sum of 2 and -12, that would be 2 minus 12, which is -10. And that does not equal -5. So 2 and -12 are not the factors that we are looking for. We then try 3 times -8, which also equals -24. And when we find the sum of these two factors, we get 3 minus 8, which is -5. And that does equal the coefficient of our x term, -5. So 3 and -8 are the factors that we are looking for. So we will break -5x into the sum of the factors, 3 and -8. So we wind up with 2x squared plus 3x minus 8x minus 12. 3x minus 8x equals -5x. And once we do this, we are left with two sets of terms that have a common factor that can be removed from each. So that's the fourth step, create two groups with common factors. 2x squared plus 3x have a common factor of x. And -8x minus 12 have a common factor of -4. So for each set of common factors, what you'll want to do is remove the greatest common factor from both sets of terms. Remove x here and -4 here. When we remove x and put that on the outside, the second factor for this term winds up being 2x squared divided by x, which would be 2x. And 3x divided by x would be 3. So x times 2x plus 3 is equivalent to this set of terms. And now here, -8x minus 12, we removed -4 from each, leaving us with -8x divided by -4, which is positive 2x. and negative 12 divided by negative 4 is positive 3. And now we have a common factor of 2x plus 3 in both these sets of terms. So step 6, remove the greatest common factor, 2x plus 3. And when we do so, we have a factor, 2x plus 3, and our second factor is x minus 4. So the factors of 2x squared minus 5x minus 12 are equal to x minus 4 and 2x plus 3. And now step 7, to check the answer, you want to multiply the factors. And the final polynomial that we get must be equal to 2x squared minus 5x minus 12. When we multiply the factors, we get x times 2x, which is 2x squared. X times 3 is 3x. Negative 4 times 2x is negative 8x. 3x minus 8x is negative 5x. And negative 4 times positive 3 is negative 12. So since our final polynomial matches our original polynomial, that confirms that we found the correct factors, x minus 4 and 2x plus 3. So that is how we go about factoring a trinomial by grouping terms. Let's now have you try a few practice questions. Question number 1, factor by grouping 2x squared plus 5x minus 3, and then check the answer. Question number 2, factor by grouping 3x squared minus 4x minus 4, and then check the answer. In question number 3, factor by grouping 5x squared plus 3x minus 2, and then check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given 2x squared plus 5x minus 3. Step 1, multiply a and c. So that would be 2 times negative 3. And that's equal to negative 6. Step 2, find the factors of a times c, or negative 6, that have a sum of b, or positive 5. Negative 1 times positive 6 equals negative 6. And when we find the sum of these two factors, we get negative 1 plus 6, which equals positive 5. And that does equal the coefficient of our x term, positive 5. So these are the two factors we're looking for, negative 1 and positive 6. So now step 3, separate b, 5 or 5x, into the sum of these factors, negative 1 and positive 6, x, giving us 2x squared minus 1x, or x, plus 6x minus 3. These two terms have a common factor that can be removed, and these two terms have a common factor that can be removed. So we create two groups with common factors by putting parentheses around each set of pairs. And then step 5, we remove the greatest common factor from both sets of terms. This set, we can remove x, giving us x on the outside. And the second factor would be 2x squared divided by x, which is 2x. And negative x divided by x would give us negative 1. So 2x squared minus x is equal to x times 2x minus 1. And for the second group, we have 6x minus 3, so we can remove 3, giving us 6x divided by 3, which is 2x on the inside. And negative 3 divided by 3 would give us negative 1 on the inside. And now we can remove the greatest common factor, which is 2x minus 1 in both of these terms, giving us 2x minus 1 as one factor, and x plus 3 as our second factor. And now step 7, check the answer by multiplying the factors, x plus 3 and 2x minus 1, giving us x times 2x, which is 2x squared. X times negative 1 is negative x. 3 times 2x is positive 6x. negative x plus 6x is positive 5x. And 3 times negative 1 is negative 3. So since our final polynomial matches our original polynomial, we found the correct factors, which are x plus 3 and 2x minus 1. That is the answer to question number 1. Let's now have a look at question number 2. We were given 3x squared minus 4x minus 4. Step 1, multiply a and c, 3 and negative 4, and that would give us a product of negative 12. And now we want to find the factors of a times c, or find the factors of negative 12, that have a sum of b, negative 4. So we'll start by multiplying positive 1 and negative 12 to give us negative 12. And when we find the sum, 1 minus 12 gives us negative 11, and that does not equal negative 4. So we'll need to take a look at another set of factors. 2 times negative 6 equals negative 12. And when we find the sum of these two factors, we get 2 minus 6, which equals negative 4. And that does equal negative 4, what we were looking for. So 2 and negative 6 are the factors of negative 12 that we were seeking out. And now the third step, we want to separate negative 4x into the sum of those factors, 2x and negative 6x. So we get 3x squared plus 2x minus 6x minus 4. These two terms have a common factor of x that can be removed, and these two terms have a common factor of negative 2 that can be removed. So we can create two groups with common factors by grouping those together, the first two terms and the last two terms. And now we can remove the greatest common factor from this set of terms and this set of terms. X is the greatest common factor here. When we remove x, the second factor winds up being 3x squared divided by x, which is 3x. And 2x divided by x would give us 2. And for our second group, we remove negative 2. The second factor on the inside would be equal to negative 6x divided by negative 2, which is positive 3x. And negative 4 divided by negative 2 is positive 2. So step 6, remove the greatest common factor from these two sets of terms. And the greatest common factor is 3x plus 2. That's common to both. So when we remove that factor from each of these, we get 3x plus 2 as one factor, and x minus 2 as our second factor. And now we want to check the answer by multiplying the factors to confirm that the final polynomial that we get matches the original polynomial. So we have x times 3x, which is 3x squared, x times 2, which is 2x, negative 2 times 3x is negative 6x, 2x minus 6x is negative 4x, and negative 2 times positive 2 is negative 4. And since our final polynomial matches the original polynomial, that confirms that x minus 2 and 3x plus 2 are the factors of 3x squared minus 4x minus 4. So that is the answer to question number 2. Let's now have a look at question number 3. We were given 5x squared plus 3x minus 2. Step 1, multiply a times c, 5 times negative 2, and that would give you negative 10. Step 2, find the factors of a times c, or negative 10, that have a sum of b, or positive 3. So we'll examine the factors of negative 10. We'll start with negative 1 times 10, since that equals negative 10. However, the sum of these two factors is negative 1 plus 10, which is positive 9, and that does not equal the coefficient of x, positive 3. So we'll look at another pair of factors that have a product of negative 10, negative 2 and positive 5. When we find the sum of these two factors, we get negative 2 plus 5, and that equals positive 3. And that does equal the coefficient of x. So these are the factors that we were looking for. So step 3, separate 3x into the sum of the factors, negative 2x, and positive 5x. Now when we do so, we have 5x squared minus 2x plus 5x minus 2. The first two terms have a common factor of x that can be removed, but the second set of terms, 5x and negative 2, do not have the greatest common factor that can be removed. So since that is the case, we want to switch negative 2x and 5x. When we do that, the first two terms have a common factor of 5x that can be removed, and the second set of terms, negative 2x and negative 2, have a common factor of negative 2 that can be removed. So we create two groups of common factors by pairing 5x with 5x squared and negative 2x with negative 2. And then we can remove the greatest common factor from both sets of terms. In this first set of terms, the common factor that can be removed is 5x, leaving the second factor of this set of terms to be 5x squared divided by 5x would be 5 divided by 5, which is 1. X squared divided by x is x. 5x divided by 5x is positive 1. And now the second set of terms, we have a common factor of negative 2 that can be removed. So the second factor is equivalent to negative 2x divided by negative 2, which would just be x. And negative 2 divided by negative 2 is positive 1. So now we can remove the greatest common factor between this term and this term. And the greatest common factor is the factor x plus 1. We can remove it from both, giving us x plus 1 as one factor, and 5x minus 2 as the second factor. So 5x squared plus 3x minus 2 is equal to 5x minus 2 times x plus 1. In step 7, check the answer by multiplying the factors. When we multiply 5x minus 2 and x plus 1, we should get 5x squared plus 3x minus 2. 5x times x is 5x squared. 5x times 1 is 5x. Negative 2 times x is negative 2x. 5x minus 2x is positive 3x. And negative 2 times positive 1 is negative 2. Since our final polynomial matches the original polynomial, that confirms that 5x squared plus 3x minus 2 has the factors 5x minus 2 and x plus 1.